Alright, so in this directory here, examples, currently there are 4 Jupyter notebooks. The first one here, let's start with registering your face. You have to write down your name here, mine is Tay, then it's going to create a directory here in your faces. You know what, let's start from the beginning. Let's say that mapping has been done, and then it will create a directory here, and then it will take 100 photos, selfies of yours. So make sure that your selfie is working. Let's load the modules and define the functions here. We're going to instantiate 2 classes, one arc face, one face detection. Currently you can either use blaze face or SFD, and then SFD is way slower but more accurate. Blaze face faster but less accurate. Let's use blaze face for this. It's going to instantiate 2, yes, and move around your face. It's going to take 100 photos. So I mean, I think 100 photos is a lot already, but so we can move around, taking photos. Alright, so there are 100 pictures taken. They're all saved here. No, actually, not the images, but directly the face embeddings, 512 dimensional vectors are saved there. So you can find, so load the faces and get the best 50 of them. It loads all these face embeddings that were saved there, and then calculates some distance, and it gets rid of the 50 embeddings that were more different from each other, and then used the only 50 that were close to each other to generate the last embedding. And now this is the final one that's been generated. So now that's going to be represent your face. Alright, and then we can do on webcam. So the webcam here, now the same directory here, your faces. Now there's only one face registered, but we can try some other. If there are more faces, then it's going to recognize more faces there. Let's try this. Load 2 modules and define the functions again. We're going to instantiate 3 classes here: age, gender, arc face, and face detection. Face detection is the one that we used before. It's going to generate a bounding box and also get 68 landmarks. And then arc face is the face embedding vector generator, and age, gender is the one that uses cropped face to estimate age and gender. Alright, run over the webcam images. I think left is not divided. Okay. SFD is pretty slow. Let's go blaze face. This is something I already wrote in to-do. There's a lot of work to do. Run over the webcam images. Here the face threshold I set it to 0.85. So if the probability of having a face there is less than this, then it would not consider it as a face. An angle distance threshold is the angle distance in radian between the embedding vectors. Only when it's lower than 1.0, then I'll consider this as the same person. This threshold is a bit higher than I think. I'm not sure. I should do more tests on this with our more faces. Alright, let's run this anyways. There you go. I mean, I just registered my face, so it of course knows that this face is me, Tay. I mean, it should, no matter how different lighting situations. See that? There's see, this face center is not perfect. Wow, what a face. That's weird, because I set the threshold to 0.85. If it's 53%, it shouldn't be considered as a photo. Face threshold, it's actually working here? No, didn't do that. You know what, I'm gonna quickly fix that. Let's fix it here. Face threshold here. If landbox is bigger than 0, and then box BB. Yeah, here, if prop is less than face threshold, then continue. Should have been done there. Let's run this again. This is the empirically chosen number. I mean, for SFD, I can be at 99 as well. Alright, then that's gonna ignore this weird thing over there, right? There you go, it's not a face anymore. That's good. Alright, so it gets me, every time it computes the embedding, face embedding, then it knows it's less than, the angle distance is less than 1 radian. It gets me. Also, there's age and gender detection running. It thinks me that I'm about 27 years old. The gender is how female this face is, so it gets about 3% confident that I'm female, which means 97% is confident that I'm a male. Face detection probability, if there's a face or something. Like I said, age, gender detection, and face embeddings are used. This cropped aligned image, 112 by 112 RGB channel, because you know that it has to deal with rotation and translation too. That's why you have to use this aligned and cropped face. Okay, let me show you how slow Blaze face is. As you can see, SFD is. It's already pretty slow. You can press escape button, by the way. Let's instantiate SFD here, and I have to work on getting GPUs as well. Already this took me a lot of time to get this 4 different neural network models to run in one repo. Okay, run over webcam images again. SFD is pretty slow, but higher accuracy, detecting faces. Now it's 100% sure that there's a face. When it comes to bounding box and stuff, yeah, it's pretty slow. The latency is because I raise my hand now, and then the hand will come up there like a few seconds later. There you go. Which means in order to produce one loop, I don't know, it's gonna take like 5 seconds or even more. Alright, there's a lot of work to do. Like I said, the face alignment is actually using only 5 landmarks. Eye, nose, and 2 mouth points. The other landmarks are not used. If I use them, probably I can get even better cropped and aligned face. Or just don't use 68 landmarks, just use 5 ones, like MTCNN. Probably it's faster. Anyways, that's the first demo. I'm going to talk about 2 other demos, how to create embeddings from videos and running on images as well.